Hey everyone, and welcome back to the channel. Have you ever played a game and thought, I could make this, or even, I could make this better? Well, today, I'm going to pull back the curtain and show you exactly how a game goes from a simple idea to a finished product you can share with the world. We're going to break down the entire process, step by step. Or whether you're a complete beginner or just curious, you'll know the path to creating your own game. Let's get started. The very first step, before you write a single line of code, is concept and planning. This is where the magic begins. You need to define your game idea. What kind of game is it? A fast-paced platformer, a brain-teasing puzzle game, or a sprawling RPG? Think about the core mechanics, the main actions the player will take. Is it jumping, solving riddles, or managing resources? What's the story? Who is the main character? And who are you making this game for? Knowing your target audience helps shape every decision you'll make later on. Once you have a solid idea, you need to write it down in what's called a game design document, or GDD. This is your game's blueprint. It outlines everything: the rules, the objectives, the characters, level designs, controls, and even the art and sound style. It doesn't have to be 100 pages long, especially for your first project, but it should be detailed enough to guide you through development. The GDD is a living document, so you can and should update it as your game evolves. Next, you'll choose your tools. The biggest decision here is the game engine. Think of an engine as a powerful workshop filled with pre-made tools for building games. Popular choices include Unity, Unreal Engine, and Godot. Unity is incredibly versatile and great for beginners, using the C# language. Unreal Engine is known for its stunning graphics and uses C++. Godot is a fantastic open-source option that's gaining a lot of popularity, using its own simple language called GDScript. For simpler 2D games, you could even use a library like Pygamy with Python. Alongside your engine, you'll need art tools like Blender for 3D models, or Aseprite for pixel art, and something like Audacity for sound editing. With your plan and tools ready, it's time for step 2. Setting up your development environment. This sounds technical, but it's pretty straightforward. You'll install the game engine you chose and its recommended code editor, like Visual Studio for Unity. The most important part of this step, and trust me on this, is setting up version control. Use something like Git with a service like GitHub or GitLab. Version control is like having a time machine for your project. It saves snapshots of your work, so if you break something, you can easily go back to a version that worked. It's also essential if you ever want to work with other people. Now for the fun part: creating a prototype. This is step 3. And it's where you build a tiny, playable version of your game that focuses only on the core mechanics. Don't worry about beautiful graphics or sound yet. If you're making a platformer, just get a square to move and jump. Can the player control it? Does the jump feel good? This prototype is your proof of concept. It lets you test if your main idea is actually fun before you spend months building on it. Test early and test often. This is the best way to validate your concept and make changes before it's too late. Once your prototype proves the game is fun, you move on to step 4, developing the core systems. These are the foundational pillars that your entire game will be built upon. You'll implement the player controls, handling all the inputs from a keyboard, mouse, or controller. You'll set up the game's physics, like gravity and how objects collide with each other. You'll also create the main game loop, which is the cycle that constantly updates the game state and renders what you see on screen. Other systems you might build here include things like scoring, managing lives, or timers, and the logic for moving between different scenes or levels. Step 5 is where your game starts to come to life, adding assets and polish. This is when you integrate all the art, animations, sound effects, and music you've created or acquired. That moving square from your prototype now becomes a fully animated character. You'll design the user interface, or UI, things like the main menu, the heads-up display HUDs showing health and score, and buttons. A huge part of this step is adding feedback. When the player jumps, play a jump sound. When they collect a coin, make it sparkle and play a ching sound. These little details make the game feel responsive and satisfying to play. With the core of the game feeling good, we move to step 6, building levels or content. This is where you actually create the world your players will explore. Using your GDD as a guide, you'll design and implement your levels, puzzles, enemies, or quests. Most game engines have built-in level editors that let you visually place objects, platforms, and enemies. Alternatively, you could use code to generate levels procedurally, which is great for replayability. This is often the most time-consuming part of development, but it's also where you can get really creative. Step 7 is all about implementing game logic and AI. You've built the world. Now you need to define the rules within it. You'll code the win and lose conditions. What happens when the player reaches the goal? What happens when their health drops to 0? This is also where you'll bring your enemies to life. You'll program their behavior, which can be as simple as moving back and forth on a platform, or as complex as using pathfinding algorithms to chase the player. If your game has power-ups, an inventory system, or dialogue with other characters, you'll implement all that logic here. No game is perfect on the first try, which brings us to the crucial step 8, testing and debugging. You need to play your game a lot. Hunt for bugs, glitches, and crashes. Is a level too hard? Is a certain power-up too strong? This is called balancing. Don't just rely on your own experience either. Get friends, family, or even people from online communities to play your game. Fresh eyes will spot problems you've become blind to. Listen to their feedback, take notes, and get ready to fix things. Debugging is a puzzle in itself, and solving a tough bug is one of the most satisfying feelings as a developer. As you get closer to finishing, you'll focus on step 9, optimizing performance. Your game might run perfectly on your high-end computer, but will it run smoothly on an older laptop or a mobile phone? You need to make sure your game has a stable frame rate and doesn't take forever to load. This involves optimizing your assets like compressing textures and audio files and profiling your code to find any bottlenecks that are slowing things down. A well-optimized game provides a much better experience for everyone. We're almost there. Step 10 is all about polish and final touches. This is where you add all the little things that make a game feel complete and professional. Create a splash screen with your logo, add a credits scene to thank everyone who helped, and build a settings menu so players can adjust volume or rebind keys. If you're targeting different devices, you need to ensure everything works correctly on all of them. This is also the time to consider localization, which means translating your game's text into other languages to reach a wider audience. Step 11. Deploy and release. You've made it. Now it's time to share your creation with the world. You'll build the final executable file for your target platforms, whether that's PC, web, or mobile. Then, you'll publish your game on a storefront like Steam itch.io, the Google Play Store, or Apple's App Store. Each platform has its own submission process, so be prepared for that. You'll also need to create marketing materials, a compelling trailer, awesome screenshots, and a good description to convince people to play your game. And finally, step 12, which is optional but highly recommended, post-launch support. Your job isn't necessarily over once the game is released. Listen to player feedback from reviews and forums. Are they finding new bugs? Do they have ideas for improvements? You can release patches to fix issues and updates to add new content. If your game is a success, you might even consider creating DLCs or starting work on a sequel. Before we wrap up, here are a few key tips for beginners. First, and I can't stress this enough, start small. Your first game should not be a massive online RPG. Make a clone of a simple classic like Pong or Flappy Bird. You will learn an incredible amount. Second, use tutorials. The official websites for Unity and Godot have amazing free resources for beginners. Finally, iterate quickly. Don't try to make your first version perfect. The goal is to get something playable as fast as possible, then build and improve upon it. And that's the roadmap from idea to finished game. It's a long journey, but it's incredibly rewarding. I hope this detailed breakdown was helpful and maybe even inspired some of you to start your own project. If you found this video useful, please hit that like button and consider subscribing for more content on game development. Let me know in the comments what kind of game you dream of making. Thanks for watching, and I'll see you in the next one.